Keynote gives me a lot of excitement to also present to you some additional things that people are doing. And I wanted to take the opportunity today to spend 20 minutes to share, the trends that we are seeing in Africa, but also in other parts of the world, in utilities and telecom. So what I'll do, just to avoid issues with bandwidth, I will just stop the video and then I will take you through hopefully some interesting use cases of GIS and how GIS is being used by water, electricity, and also telecom organizations. Just a quick touch, Biko, the sound is coming okay from your end?
It's perfect.
Okay, perfect, excellent. So like Biko was mentioning, my name is Chrystelle Ourzik, and I'm the Africa and Middle East Business Development Manager for Utilities and Teleco at Esri. Very excited to be presenting to you today on the GIS trends in utilities and telecom, because really this is a topic that I'm really passionate about. I've been in that industry for, if you're following me on LinkedIn, you will see that it's showing like 18 years, but it's a little more than that because I was part of that industry, also working at a telecom company in the previous years. So in my role at Esri, I have the privilege to see how utilities and telco customers use GIS to solve the many problems that they have daily. And I'm looking forward to really share some of my experiences and hopefully shed some light. It's not moving forward for some reasons. I might just exit. Okay, just a technical issue. Maybe I have. Okay, that's it. Just not in sync, but things are okay now. So I will just start off, and I'm sure you're aware, of course, because most of you are from utilities organization and telecom companies, that you are facing continuously, unprecedented challenges. And for many organizations, really, it's a combination of known issues, such as maybe aging infrastructure, but also unknown, right? Like unforeseen impacts due to things like natural disasters, or even the COVID-19 pandemic, as we are all unfortunately in it at the moment. In addition to these challenges, utilities and telco are under more pressure than ever before to actually change their operation and their operating models, to change their processes and change their behaviors, of course, as a result of constant grid, whether it's electric or water, and network technology advancements. We're going to talk a little more about this on the next slides. Constant change requires better understanding and better communication and collaboration among staff, that's for sure. And also it requires a need for modern enterprise information systems and tools to ensure better decision-making and to support the business. And Clifford initially kind of touched on that. He talked about the various systems, the system of records, the system of insight, and the system of engagement. And throughout the conference, you will see several examples of how that looks like. So the next slide that I want to cover with you is actually to discuss a little bit, the business drivers that we are seeing and how this is evolving primarily over the past 2 decades. So let's take a quick look. While the industry has, being quite slow in the adoption of change, and that's primarily for electricity and water, right? Really, for the past 2 decades, compared to what has happened over the last 100 years, really that's when most of the changes took place. So when it comes to back in 2000, for example, it might be a bit hard to believe, but the concept of IoT and grid sensors was actually introduced back then already. It's not something that is quite new. It's already 20 years ago. It was amazing technology actually at the time, and it was introduced to, as you know, connect everything to everything, right? That was kind of the promise. And the idea was to create new insights and situation awareness from interconnection of things. Unfortunately, this IoT revolution was very slow in terms of gaining momentum. It was largely due to the lack of supporting infrastructure, high cost and large processing power requirement to deploy these sensor networks. Today, it's a very different story, of course, because there are so many of those projects that are happening. Back in 2004, then we started to have more and more of those smart grid projects, right? So, and the idea was to, for utilities to invest in a rollout of advanced metering infrastructure and smart meters, right? The goal was really primarily to improve reliability, of course, and give customers the choice also to maybe implement new grid intelligence through things like self-healing networks and automation. But in reality, it was difficult to achieve an initial return on investment, and that's the feedback we got from those customers. And it was largely due to data, and actually big data, that I should say, because as you know, smart meters, they can push quite a lot of data. Then, came along the grid modernization era. And in the late 2000s, we began to see the emergence of a new program around grid modernization. There were numerous facets to this, but it was largely, I would say, a reaction to the needs of upgrading the aging infrastructure and to create solutions to manage the modern grid, including what we call the distributed energy resources, for example, and microgrids that Clifford was referring to earlier on. Grid modernization was also tasked to break down silos, right, within organization and to bring together more this notion of OT and IT conversions. This was the bringing together of operational data from SCADA system, for example, right, with other corporate data, such as the one from enterprise assets management or even GIS for that matter. And so this project also experienced some significant setbacks due to multiple data sources, right? Where is that platform that can bring all of these data? And we will see how GIS is really helping with that regard. A lot of legacy integrations, and I'm sure that speaks to you, right? And custom applications, and of course, challenges due to the poor, or maybe I should say the lack of data quality. That's, of course, something that everyone is experiencing. This data issue of quality, completeness, accuracy, that's always a topic that comes back on the table. 2012, we're looking more at what we hear, which is related to digital transformation, right? So this is the adoption of mobile devices, more and more enterprise workflows, right, that are replacing legacy paper-based workflows. We saw some great examples. The one that I caught my attention was the one in Zanzibar, where they were using the Survey 123 technology from Esri and doing some data collection using the Survey 123 application. Digital transformation programs and projects are still ongoing. There isn't today really an organization that is not going digital or even having a digital entity within their organization. So this digital transformation programs and projects, they are still ongoing, that's for sure. But one thing that is really important is change management, right, to ensure the success. So the technology is a big part of solving multiple problems, but change management and change is not just, yes, it's people for sure, but it's more, right? There's an ecosystem of other factors that need to be taken into consideration. And that's a big part of ensuring project success. And that applies very much for GIS as well. So today we are now close to 200 countries, actually 190 plus, and many utilities around the world are embarking on what we call this energy transition, right? And the idea is to reach strategic decarbonization targets, of course, and to deploy as much as possible green energy solutions. So I'll show you some example of what that means for GIS and for you, and how you can use GIS for that. And while many utilities are still in the early stages of incubating this strategy, we're already seeing some great successes around and coming from from a new thing that is coming up, and that's actually the digital twin. We'll talk about how that looks like, and so that you kind of project yourself on this new type of projects happening at the moment. Okay, so the purpose of the next slides really that I wanted to share with you was really to address the business problems that GIS is solving. And oftentimes we get very quickly, attracted by the tech, and we feel like, yeah, great tech, demos well, I can do this, can do that. But let's make sure that we always start with the why and what type of problem we are really trying to solve with GIS. So not everything is going to be covered in my presentation, but I wanted to kind of classify a little bit the various topics, and then I will drill down in those topics. So I like to think about it in kind of 4 main categories, as you can see here listed on the screen. GIS has always been used, as you know, for planning and siting, right? So as more and more energy production technology becomes available, utilities all around the world, and even, you mentioned, Clifford, right? Many of those projects in Eastern Africa, utilities need to plan for further electrification programs, right? They need to plan for providing access to water, both in rural and urban areas, and to plan for various scenarios, right? To ensure that either, and when I say the modern grid, modern can be water or electricity, and to ensure that the modern grid will actually be ready to be more reliable. And the same goes as well for the telecom network connectivity. Of course, a lot of planning is required for that. And we'll see what technology is being used for this type of main key classification requirement. The other part is better asset management. And there is a lot, that digital transformation projects, comes and play in this. There is also the topic of real time. So like, how do I do better real-time asset management, and what does it mean? And it requires, of course, some seamless digital workflows combined with, and I'm quoting here a colleague of mine that I spoke to yesterday, and he used this expression, and I like it. He said, it's the geospatial experience, right, that people have, and I maybe that's something you want to take a note of. And when you start to implement new projects, how do I bring that geospatial experience, right, to ensure that some of the workflows are always accounting for somehow the asset location, or maybe the, and when I say asset, it can be the network asset, but also the employee location, the crew location, the customer location. So anything that has a location and that the utility needs to worry about, right, when they do their business. So the idea, of course, of this better asset management category is to primarily improve operational efficiency, right? So this requires a new approach with modern data, and we see what that means, modern data. Modern GIS systems, specifically when it comes to the architecture, it has to be based on something that is not just client server, but more web services oriented architecture. And we'll see, 3D is coming, into the play as well, and playing a huge role here. You may have heard that we have a current flagship product, and that's the Esri utility network, and there will be presentation on this going forward. So I won't expand on this too much, but really that's a part of the new way of doing better asset management. And also, of course, there are a lot of things around 3D imagery, reality capture, augmented reality, virtual reality, even BIM, right, that are extremely trendy at the moment, which I'll show you some examples so that you can see how that looks like, including digital twin projects initiative. So better asset management also requires analytical tools, right, to understand and prioritize actions on assets that are most likely to fail, for example, and assess the consequences of failures and risk of exposure for the business. We'll share some example of how actually artificial intelligence and GIS play in this. Better asset management requires also holistic situational awareness, right? Understanding the full context, right? Not just the network on its own, but what's also around the network and all of the activities and dynamics around the network. And also dashboards, right? We saw several examples of that early on from Clifford that we shared, and to really understand what's going on on the network, right? Where are the outages? Where are the water leaks? But also where are the crews and where are the work orders? And how long does it take, right? And the time to resolution. And I would just say on this slide that, just to kind of end this slide, is that ArcGIS, what we're seeing is becoming the de facto standard for integrating all types of operational and non-operational data. So we come back on that. And of course, the last one, but not least, safety, business continuity. With the pandemic today, there are a lot of things that are happening with regards to how can I use GIS to ensure business continuity and ensure that there is safety for my employees, but as well as for my customers. Here, this slide is an interesting one, and I like to bring it up because really what utilities are doing more and more, they try to understand their network and customers through location. And this is not necessarily new, right? But utilities and telco do not want to operate blindly. And that's why they choose to use GIS, because it really helps better understand their customers and their networks through the use of the location information. You see here, there's a long list of items, some of, data items, some are more like, activities, right? But if you see what we can use and bring together using the GIS and the geospatial infrastructure that was mentioned earlier on, you can then really get fantastic insights or provide your users with information and patterns that really are helping you to better run your business. So extremely, extremely powerful tool, right, to have an integration of all data types and sources. So let's see some examples showing the value of GIS and the problems that utilities and telcos solve with GIS and location services. Let's start with the planning part, right? So microgrid siting, wind farm siting, nothing really new, but really having the ability to bring, like you can see here, whether it's imagery, whether it's any type of information that you would require to do this type of analysis, right? So GIS information can assist with microgrid project developers in determining, for example, which area to target and the type of technology to make up and to include. Information such as spatial patterns, solar irradiation levels. We have that as well as part of our atlas. I'm not sure if you're familiar, but we have a living atlas that provide this type of information. Also like average annual wind speed, access to waterways or hydropower, for example. All of those are available as part of our atlas. And it's actually the Africa Geoportal. You can take a look at this, and Biko and the team can provide more information on this. Even the distance, for example, right, from the rural areas to the closest town can be used as a criteria to assist in determining the viability of transporting diesel, for example, for generators, right, from a cost perspective. So you can see here how you can very quickly use all of those data sources, put them all together, and then use the GIS tool to perform your analysis in order to find the best placement and do the siting for microgrids, wind farms, and many other power source for generation, production, energy production. On the upstream of the grid, also many organizations are looking at doing like what we call atlases for wind and for solar. You got a couple of examples here, but also downstream, you can see here some examples. This is one of our customers here in Dubai, and they have used the ArcGIS technology in order here to create what we call a solar calculator. So the idea is to provide the people with the ability to assess potentially if I were to put a solar panels on my rooftops, what would be the cost, and also the CO2 emission reduction, right, that I would contribute to either as an individual, or maybe if I am a commercial customer. Last one, you can see here on the bottom right-hand side, there is solar panels with some red lines, and this is actually drone that are flown around the solar panels for a solar farm, right? And you can see here we are detecting defects just from the imagery. So fantastic tools here to assess those. Now here, what I'm showing you is something that, I touched on the digital twin, but still on the topic of planning, right? As you know, the telecommunication industry is moving extremely fast, right? Telecom companies need to make more and more, decisions in a way that is so fast, right? They need to ensure also effective service, and that they need to deliver next generation network management, next generation networks, right? So they need those tools and those management tools in order to do that. So the ability of a company to successfully deliver today next gen networks is really dependent upon the quality of the data, right, that is available, and how they plan, right, and deliver networks capable of providing the highest quality products and services, of course, to the customer that are demanding it. So there is, of course, this new trend of 5G, but there are also other technology, whether it's 4G or fiber, that are trying to be planned as much as possible. So as an example here, and this is shown at the top left of your screen, right? The planners and engineers, they require highly accurate landscape, building, and network information in order to make the best decision for fiber design, for example, or 5G small cell deployment. And by leveraging a digital twin, engineers can design with spatial accuracy and perform line of sight analysis, right, for optimal network designs. So Telcom can also integrate, like detailed CAD files, for example, to allow for highly detailed models to be visualized, but not just visualized, but visualized in context, right? So here you can see how the cell tower is interactive and how you can also trace downstream to show the end-to-end connectivity. And this connectivity can be traced all the way into a building, as you can see here, modeled across building floors and all the way into racks and ports of the network, and then visualized in an easy way to manage the schematic views. I've seen what customers are doing. To be honest, this is really amazing thing and stuff that shows the power here of the technology, and is a full end network management for telecom that can be provided to our customers. So we're very happy and proud of this new development that is now available for telecom customers. Okay. Single Imagery solutions for you. The team can share, all the links and stuff. But here, I just want to give you an example of so you will see here towards the end of this, you will get a sense that how you can measure the total penetration distance from one end location. So this scene view that you're seeing here is also symbolizing antennas thematically from a distance, and you can have a more realistic up close using visibility ranges. So again, you can see here that there is this new trend moving away from just the 2D type of planning and analysis. That's kind of how I started, but I wanted to take you to the next level, which is what organizations are working on now, and funding projects for more like of those 3D contextual planning solutions, so that they can really have a plan that is more accurate. Now, for electric utilities, I think the story is just as amazing, to be honest. And there are some great examples here that you can see on the slides. Organizations are using GIS to better understand and plan for events like natural disasters. We talked about this earlier on, but really understanding, as you know, precedes action, right? And by knowing where areas of your network are prone to things like it could be earthquake, but I think in your part of the world, it's mainly issues related to weather, right, and weather events. Here the planning really can be optimized not only by understanding potential impact to your network, but also planning evacuation routes, for example, and staging areas. Real-time outage situation awareness is of course essential, right? When you have weather events, so anything, any type of event happening on your network. And this is when GIS becomes the operational dashboard, right? For aggregating and monitoring things like outage events. So this information is delivered in easy to understand reports, which can then be shared, of course, internally, but also externally, right, to aid in information transparency with the public and the decision making at the high level, even at the state level in some cases. But what is the most exciting, I think, for utilities is how they are embracing 3D capabilities. For example, for substation maintenance, crews cannot be provided with just a single dot on map, right? I mean, I don't know how you're doing and modeling your GIS today, but when I'm sure you've realized that if you just model a substation which has so many components internally just as a dot, or even if you have multiple, you might end up with multiple dots, even if you're trying to just stay on the dots and line type of representation of your assets, then that's where you will have hundreds of assets all in the same location, right? It's very hard to manage. So with the deployment of the utility network, our flagship products that I mentioned earlier on, these can now be visualized accurately using the concept of what we call containment. So it's very straightforward. It's like what is contained within, for example, a substation. Well, there are multiple assets that are within the substation, so we can model that, and we can also provide excellent representation on a map, whatever scale you're at, so that it's easy for the cartographers to provide a really nice and easy map, to use, whether it's in the office or out in the field, but also having that model so that then when you need to integrate with other systems, you have all of the information handy. And you can look also at integrating to other design solutions, bringing in interactive 3D models, which are not only they look fantastic, but I think looking fantastic is one thing, but really what you want to do is streamline the field operation workflows, right? Now let's switch back maybe a little more back on the 2D representation, but still, very, very trendy and useful. It's all of the situational awareness type of dashboards that people are looking to put in place, because it's really an easy way to communicate with the rest of the organization. So you have some great example here, whether it's situational awareness related to outages on the network, or maybe some lightning warnings or real-time outage and number of customers affected, and of course wanting to know the estimated time of restoration, and that requires integration with your LMS and your CRM in the backend. Again, GIS is the integration platform allowing to have multiple systems within information system within the organization, but really bringing this and at the spatial level, which provide you a view that no one else can provide. We are hearing more and more of those GIS projects, integration with ADMS, and this is why we have more and more projects also of organization jumping onto the utility network in order to have the language from the two systems, that is smoothed out. So by this, I mean looking at modernizing your data from the GIS perspective so that you can have a smooth integration with GIS, with the ADMS. Emergency management. Well, when there is a valve that needs to be closed or isolated, you want to act quickly, right? Especially when there are multiple leaks, or even if it's a big, huge water leak. Of course, the sooner you act and the sooner you can resolve that issue with the leak, the better. So doing valve isolation trace, mass email notification to notify customers affected by an water outage. I mean, all of this, we have a full suite that can help you with the full workflow. And please reach out to Esri Eastern Africa team if we want to have more details on how this could be implemented within the organization. I think the small utility LA program will really help you, put in place this type of solution to really solve the problem of non-water revenue, as well as reducing the number of leaks and the waste of water. Talking about water, here's another example for here where you can see the full underground network, because we spoke a lot about above ground assets, but there is also the, another life underground for some utilities, and that can be, for example, for wastewater or water treatment plant, for example. You can see here on the right-hand side, this is a BIM model. So the data was actually, they used LiDAR to collect the data, then they created the BIM model, and then it was, you can see it's overlaid on the actual assets. So that provides the ability for a field technician, when he goes on site, he can be on his tablet, and then he can see all of the maintenance information related to those assets. So you're mixing the virtual and the reality network in front of you, which is quite amazing. So GIS is really the process and framework, right, that enables you to integrate and interconnect all those different models all together. Now, I want to switch gear a little bit, but I want to address one thing with regards to asset management and better asset management. And many of you have either started some initiative to integrate with your enterprise asset management. Here, I'm just using the courtesy of one of our partners. This is a partner screenshot, Specialytics. But the point I wanted to make here is that when we talk about the life cycle of the asset and the maintenance associated with those assets, let me just take a minute to explain what you're seeing here on the screen. So to leverage, the spatial information as well as the maintenance information stored within, for example, SAP, right? So you want to merge both worlds, right? So into one same user interface. And here the user is provided with this geospatial experience, which provide not only the maintenance information, but also the contextual information, right? So if I'm a work order dispatcher, I can see all of the work orders, where the distribution of it, and I can group them and assign them to the nearest field technician that has, of course, the skills to perform the task. So I don't go blind in my work orders assignment, right? I think this is what's key. If you're just using a system where everything is tabular, or things are like multiple windows, how do I make that decision of optimizing how I dispatch my people? So that's the beauty and the value really that GIS can bring when you start to geo-enable many of those other information systems. And here, this is the example of geo-enabling SAP for maintenance work orders creation. So if you do that, then you will create a record in the SAP, and the geometry and the location of the work order will be in the GIS, right? There will be no replication, things will be nicely integrated. And then it will help you leverage the information of both best world, of course. And you can, of course, you make the decision where you want the data to be stored and maintained by what system and so forth. So these are the type of projects that people are doing. Continuing on the asset management, we talked about dashboard a lot, but I just want to also make the point here that if you do integration with, for example, a customer care system, or with an OMS system, or even social media information, or any type of vegetation hazards, right, that you have and you're recording, you can see how you can bring this all together, and then you can provide a holistic view to the end users so that they have a better sense as to what's going on in the network, right? Now, this slide brings me to something that is very trendy at the moment. And when you talk about predictive maintenance, there are different strategies, right, that people take. Some people look at strategies more related to time. By this, I mean, they know that some assets are going to eventually fail at some point, and that's related to the time that they've been in service. Some people look at the conditions, meaning, yes, I know that time-wise, some assets will fail, but I just look at the conditions. So I base my maintenance programs on the condition of the assets, and that requires, of course, to have that information. But there is more a trend now to look at the maintenance more from a reliability standpoint, right? So that means that I need to be smart in bringing not just information related to the conditions of my asset or the age of my asset, or, I know when my asset will fail because it's been in service for X number of years. No, you can bring all of this into one, environment, but you can also go above and beyond and start to look at artificial intelligence to even bring imagery, soil information. I mean, you name it, right? So here, this is an example from our partner, Voda.ai. I have the courtesy of using this thing that they have. They have a model that enables actually here to look at the most likelihood of assets that will fail, as well as the consequences of those assets failing, and what risk this is exposing the business to. So extremely, extremely good use case of how you can bring, again, all of the spatial information as well as operational data into one model and then provide you. So what you're seeing here on the screen, the red pipes, or the pipes that are the most likely to fail, which means calls for action. Take a look at those pipes first and then do maintenance on it as soon as possible to avoid leaks and issues of pipes that will might have damage and explode or create water leaks, for example. Grid reliability. Here, as you know, GIS has often been used to assess patterns, and here this is an example of looking at outages here, for example, of an electric utility, and trying to assess, are we observing new patterns, right? So things were fine, and that's defined as the blue, but when you start to see some red groups of squares here on the screen, that means that there is most likely what we call hotspot, right, and issues with the network. So this is looking at new emerging hotspots of outages. Coordinated operations. I know that there is a session later on this, but of course, there is this concept of 3 C's, right? The coordination, collaboration, and coordination. So it's good to have in the field phones, and people talk a lot over phones and they do things over the phone. But if you provide the users with the ability to do things more by providing them with maps and spatial information and contextual information, then you will get a lot more value to better communicate and coordinate activities within the field. We have, I'm sure you know, a full set and suite of field operations application here. These are just some screenshots of how you can easily do inspections in the field. And not only we have the core tech available, but we also have configured solutions that you can download from our site, the solution site, so you can easily get going in implementing those field workflows required to either do inspection of assets or maybe collecting additional information that you don't have handy and you require for your business for a variety of analysis. So these are just screenshots showing, for example, specifically here for water, as you can see, like the hydrant maintenance inspection, the valve exercising application, backflow preventer inspection. I mean, there's a long list, including like CCTV inspection, for example. Now we at Esri, we like to talk tech. So this is also the courtesy of another partner of ours. Here the idea that I wanted to bring home was just to show you how you can bring then virtual augmented reality information onto your network. And you will see here as we get, there is a slider on the side that enables you to see also the assets underground. So that requires, of course, to have data collected, available. How do I show these underground assets as if it's almost real? Of course, that means you need to collect that information when the trenches are open. So this is not something that you're building and recreating, but there is the data collection part that is very essential, and there are many tools to collect that data so that then you can come up with this reality, mixed reality type of views, right? So you bring the information related to your assets and the maintenance of your assets that are stored in your various information systems, and you use the GIS in order to bring that and lay that out on your actual assets outside. And this can be used using, of course, tablets, phones, as well as special glasses. I'm sure you've seen some of those already. So I know that you have also a lot of issues with vegetation in your area, so I just want to bring up how you can do, for example, transmission line monitoring using drone imagery, and you also have an example here on the right-hand side of a drone tower inspection, where you can use our tech called to collect the drone imagery, and then use that to assess if there is any inspection that are required on specific, like for example, here it's an insulator that needs to be inspected. I mentioned one of the main categories as well of big trends, and that's really how you engage with your customers, right? So there are many activities and the digital transformation happening in the organization, but also how do you push information to the public and to your customers? So, of course, providing the ability to do things like public-facing outage views are very, very trendy. But also on the environmental side of things, sometimes there are utilities that provide information to the public so that they can offer comment, for example, regarding a new proposed transmission line. So map and dashboards are becoming pervasive. I'm sure you've seen over the past 12 months the multiple dashboards being put in place. You've put some in place for your own organization. And this is really something that is becoming more and more trendy. But it's not just, it can be real time as well as looking at things that are a bit more static. Also important is dashboards are sometimes more like for corporate management people. So you can see here that this is more looking at holistic aggregated information, excuse me, regarding the reliability of the network, right? So the SID and the SIFI, maybe looking at customer satisfaction information. And here the beauty of it is that you're not going to go and fix some specific issues, but more looking at holistically the areas that really needs and require attention. So that's also a very, very strong power of having the ability to aggregate, correlate data, then visualize it so that management can take the best decision going forward. So this brings me close to the end of my presentation. And here you can see the summary of how GIS provides excuse me, strategic capabilities to meet the strategic initiatives of telecom and utility organization. And we have the first initial slide that Clifford showed for the various systems, right? The system of record, system of engagement, and the system of insight. All of this, provide capabilities like field mobility, real-time, emergency response, business intelligence, and so forth to meet the industry mission. Finally, I'll touch on the concept of digital twin, because really that's what we are hearing more and more, that more and more projects are being planned. Actually, 70% of organizations, according to a recent survey, are in the planning process to implement digital twin in the next 1 to 3 years. So I'm not sure where you stand on this, but I'm pretty sure you have also some of those projects being budgeted at the moment. And leaders are beginning really to understand that in order to generate the expected outcome, they need to think geospatially. So we are happy to work with you and help you so that if you have requirements within your organization to help to meet those requirements and help your leaders to bring a digital twin alive in your organization, we'll be more than happy to partner with you on this. And the digital twin is not a single magic solution, right? It's not just like the GIS going to do it. It's it requires multiple things, right? And it includes the requirements of multiple transformation programs like IoT, smart grid, grid mod, and energy transition. So what it requires really is the interconnection and integration of many types of digital twins something that can only be achieved in our perspective and view really with GIS. As you know, you can bring all a variety of data, but also a variety of information system and variety of digital twins. So by this, I mean, it's the digital twin of your network, the digital twin of the street network, the digital twin of the buildings. You know, there are multiple digital twins that you can bring together. So with that, I'm sorry, I'm losing my voice a little bit, but I hope you've enjoyed this presentation, and I will leave you with this final takeaway. If you're considering deploying a digital twin, remember one thing: GIS is the foundation for your digital twin. And I really thank you for your time, and I hope that you will have a great conference. If you have any questions and you want to know more about specific topics you saw today so far, please reach out to Biko and myself. We'll be more than happy to support you. Thank you.
Chrystelle, that was really great. I'm sure the audience really enjoyed